infected by a virus, then obviously your body fights the infection. Later on in infection, you start making what we call the adaptive immune response, which consists of antibodies and cytotoxic T cells, and these are usually the things which finally clear the viral infection. However, they take maybe 4 or 5 days before you start making antibodies and adaptive immune responses. Even within a few hours of becoming infected with a virus, you start making what we call innate immune responses. Now, these innate immune responses are the same type of response regardless of what virus you're being infected by. Foremost amongst those innate responses is something called an interferon response. And interferon is, in its own right, is a really powerful antiviral system. And actually, it's such a powerful system that if it worked to its full capacity, it could probably control most virus infections in the absence of antibodies and cytotoxic T cells. If a cell becomes infected by a virus, then the cell will respond by producing this substance called interferon. And the infected cell will secrete interferon. And what interferon does then is it signals to neighboring cells, viruses produce products which prevent the interferon system from working correctly. And it does this by binding to receptors on cells, the interferon receptors, which then activates an interferon signaling cascade, which leads to the upregulation of hundreds of cellular genes, the products of which have antiviral activity. So you induce what we call an antiviral state in these uninfected cells, which makes it difficult for a virus then to replicate in cells which are already in this pre-existing antiviral state. So some viruses are really simple. They only produce, I don't know, maybe 6 proteins or 6 products. But one of those will be specifically to prevent the interferon system from working correctly, okay? These simple viruses, they don't actually bother about trying to block antibody responses or cytotoxic T cells responses, but they must do something about the interferon system. So basically what we do is, our research is trying to understand how the interferon system works, how it controls viral infections, if it's working correctly, but also to understand how viruses prevent the interferon system from working correctly. The work is of fundamental interest, but in addition to that, it can lead to some practical applications.